Hi friends, welcome back. This is Vijay Kumar Sape, lecturer in EEE, Karaikal Polytechnic College, Karaikal. In today's discussion, we're going to have another important topic from the subject distribution and utilization. I hope you guessed the topic. Yes, it is about electric traction system. The contents of this presentation involves introduction, why electric traction system, types of electric traction, types of track electrification, single catenary construction, systems of track electrification, major components, components of an AC locomotive, and conclusion. Coming to the introduction part of this lecture, first of all, let us see what is traction. The process of moving any vehicle on track is called traction. If the electrical energy is used for this process, then the system is called electric traction. The classification of traction is broadly classified into two groups. The first thing is non-electric traction system, that is mechanical system, and the second one is electric traction system. The non-electrical or mechanical system involves steam engines and IC engines, whereas electric traction is driven by railways, trams, trawlways, etc. Why electric traction system is preferred? The first and foremost quality of electric traction system is cheapness, or the cost of operation is very low, and you can expect a lot of savings when it's compared to conventional traction systems. Cleanliness, that is, electric traction is completely free from smoke and gas, and you can have a clean atmosphere. Maintenance cost of electric traction system is almost half that of steam engines. Starting time and speed, that is, the electric traction system can be started instantly without any delay. High starting torque. The motors that are used in traction are DC and AC series motors, which are naturally have very high starting torque. And the braking system. This is one of the greatest advantages of electric traction system. The electric traction system employs regenerative braking, which saves a lot of energy and which can be done only in electric traction system. And saving in high grade coal. The electric traction system saves a lot of non-renewable energy sources and environmental friendly. Types of electric traction system. Electric traction systems are classified into three types: DC traction, AC traction, and multi-systems. In DC traction, the supply is fed from a overhead line or conductor rail system. The most popular voltage for overhead wire supply system is 15 kV DC or 30 kV DC. And 600 volts 750 volt DC supply is used for conductor rail system, which will be laid as a third rail system. And this is the schematic for DC traction system. Of course, it has got some of the disadvantages. This system is expensive, and it requires substations at frequent intervals. The overhead wire or third rail must be relatively large when compared to AC system. Voltage goes on decreasing with the increase in length. That is, there is a considerable amount of voltage drop on the traction system. In AC, on the other hand, AC traction system has a lot of advantages. Like AC traction system, the typical voltages used are 25 kVA, 25 kV AC at 50 Hz frequency, or 25 kV AC at 60 Hz frequency. In India, we are following 25 kV AC at 50 Hz frequency, whereas European countries and US are following 60 Hz AC supply. Advantages: few substations are sufficient for AC traction system and compared to DC. Lighter overhead current supply wire can be used so that this supports reduced weight of support structure and reduced capital cost of electrification. Coming to the system of track electrification, trolley wire or contact wire suspended with a minimum sag so that the contact between the trolley wire and the current collector can be maintained at higher speeds. This wire is supported by another wire known as catenary. Two different types of catenary constructions can be used: single catenary or compound catenary. And here are the diagrams which you can see the overhead line supplying the locomotive. Type of track electrification: single catenary system, wherein you have a catenary and droppers. Vertical lines are called droppers, and these are suspended in between two supporting towers. And the straight line, which is almost in parallel with the ground, is called as contact wire. Provided for speeds up to 120 kilometers, a span of nearly about 45 to 90 meters with a sag of 1 to 2 mm. Relatively cheaper and less maintenance, and suitable where traffic is denser more and operating speeds are low. Whereas this compound catenary construction system, it's somewhat different in construction, and it is one of the advanced structure of supplying the electrification for the traction. It is provided for speeds ranging between 190 kilometers to 220 kilometers per hour, and India is setting uh, some of these projects under construction in India. Single catenary construction, you can see like this. You have a running rails and electrification is applied through overhead system, and this wire which is running on top is called catenary. The vertical lines supporting the conducting wire, contact wire, are called droppers, and the green one which is running on top of all is called as return path. And these are all booster transformers connected in between to maintain the voltage levels. Types of current collectors. So by seeing the picture you can identify that this is called as a bow collector. A bow collector is one of the three main devices used on tram cars to transfer electric current from the wires above to tram below. And it has got some of the disadvantages. The main disadvantage of this bow collector is the traction system is unidirectional. And to overcome this bow collector, nowadays all the current collectors are replaced by pantograph collector, which looks like this, and which can be driven on either sides. Next is the major components of electric traction. That is, first we should have a traction substation, overhead wiring, current collector, track, and track system, that is our locomotive. And it looks like this, and we have an electrical substation to step down the voltage to required levels, and it is supplied on top of the wire. This is called as catenary, and from catenary the supply is given to the droppers. From droppers it is going to the conducting wire. From this the current is collected from power is collected from overhead lines through pantograph, and it is applied to the speed control system. From speed control system it is supply is given to the electrical motors, and it is driving the locomotive. And return path is provided through track. This is how electric traction works. So these are some of the components of AC locomotive, and here AC locomotive will also have a transformer on it and some of the converter circuits. So this is excluded in our syllabus, so I'm not going to deep about it. And traction motors. So DC series motor is one of the motor used for electric traction because it is having very good starting torque and low torque at the high speeds. This is what exactly needed. And here is the diagram for DC series motor. And these are the characteristics. As we all know, speed curve characteristics, speed torque characteristics. If you observe, you can have a very high starting torque at the starting, which exactly suits the traction system. And coming to the braking of traction system, the traction system employs plugging is one of the major braking methods in electrical braking. Plugging means reversal of torque. That means the phases are interchanged to produce torque, and the braking is applied. In this braking, it has got the disadvantage of wasting the power as well. And the second method of braking is rheostatic braking. Here also the armature is disconnected from the mains and it is connected to a braking resistor in which the power is wasted. And the third type of braking which is employed in all electric traction is called as regenerative braking. This involves whenever there is a excess power in the motor of the system, then that is fed back to the supply through converters. So this is the most efficient and energy saving braking system employed in traction. So coming to the conclusion, in this presentation we have seen that no single motor is ideal for traction purposes, but DC series motor are most suitable for this work. Power electronics has been restored to in a major way for conversion and control operations. Different type of braking were discussed out of which regenerative is most efficient. The electric locomotives are more efficient than steam diesel locomotives. And I welcome any queries or doubts. You can make it on the comment box below. Thank you, students. Stay at home and stay safe. We'll meet you in the next lecture. Thank you.